Hello and welcome to Study Space. Today we are going to start a new series of videos in which we'll be solving the questions that were asked in various exams this year. Okay, so we'll be starting off with the questions of Jest 2019 और सबसे पहले हम लोग quantum mechanics के questions को देखेंगे. Okay, so let us start. The first question is, consider a system of 15 non-interacting spin polarized electrons. They are trapped in a two-dimensional isotropic harmonic oscillator potential, which is given to be V of x comma y is equal to half m omega square into x square plus y square. The angular frequency omega is such that h bar omega is equal to 1 in some chosen unit. So what is the ground state energy of the system in the same units? अब देखो इस तरह के क्वेश्चंस को करने के लिए सबसे पहले you have to look into the form of the potential. In this question, it is given to be an isotropic harmonic oscillator. Now, isotropic means that the omega associated with each direction will be same. Okay. Now, if that is so, the energy of this system can be easily written if you know the energy for a one-dimensional harmonic oscillator. Okay. Now, the energy for a one-dimensional harmonic oscillator is known to be n plus half into h bar omega. And since here you have two directions, therefore the energy for this system can be written to be nx plus half into h bar omega plus ny plus half into h bar omega. Okay, so here we are taking omega in the x direction and in the y direction to be same because the oscillator is given to be isotropic. If it was anisotropic, we would have taken omega 1, let's say, for x and omega 2 for the y direction. Okay. So in this particular case, the E comes out to be nx plus ny plus 1 into h bar omega. This nx and ny are the quantum numbers associated with the system. Okay. Now you see here that nx and ny occurs in the problem in a specific combination, which is nx plus ny. What it means is that if you change nx and ny, but make sure that nx plus ny does not change, then the energy of the system does not change. Okay? This means that for the same energy, you can have different configurations of nx and ny. Okay, this will become clear if you see the energy level diagram for this system. Now, this is the energy level diagram. Here you can see that for E is equal to 1 unit, you can have nx and ny is equal to 0, 0, and no other combination is possible. But for E equal to 2 units, you can have nx, ny is equal to 1, 0, or you can have nx, ny is equal to 0, 1. Now, when this happens, we call the state a degenerate state. Okay, that is, whenever two or more states are having the same energy, those states are said to be degenerate. Okay, so here you can see that the ground state is non-degenerate. The first excited state is two-fold degenerate. The second excited state is three-fold degenerate, and the third excited state is four-fold degenerate. Okay, so in this scheme of things, you need to fill 15 electrons. Okay, starting from the ground level. Now, how do we fill those electrons? That requires you to know that electron is a fermion. Now, a fermion has to obey Pauli's exclusion principle, which says that no two fermions can have the same set of quantum numbers in a given system. Okay. More simply, for electron, it says that no two electrons can occupy the same quantum state. This means that if we start filling the electrons from the ground state, there will be two electrons in the ground state. There will be four electrons in the first excited state because there are two degenerate levels, each of which can have two electrons. The second excited state can have six electrons. The third excited state can have a maximum of 8 electrons, but we have only 15 electrons, and therefore one of them will have 2 electrons and one of them will have 1 electron. See, here I have shown that those 2 electrons belong to 2 comma 1 level, and the single electron left after filling up 14 electrons is in 1 comma 2 level. Okay, now this is not rigid. Okay, which means that you can have those two electrons in any of these four states, and the last electron in any of the other three states which are left after filling the two electrons. Okay, that doesn't change the energy of the system. The configuration of course changes, but the energy of the system doesn't change. Okay, therefore you can fill the electrons in whichever way you want. Now, if you fill like this, you would see that the energy comes out to be 2 into, now this 2 comes because each of the energy levels here contains 2 electrons. So 2 into 1, which is the ground state energy, plus 2, which is the first excited state energy, plus 3 plus 3, which is the second excited state energy, and plus 4. Okay. Now, apart from this, you have to add another 4, which corresponds to the electron, which is singly occupying the 1 comma 2 state. Okay, now if you do this, you would find that the E comes out to be 40 units. Let us see the second question. For a spin half particle placed in a magnetic field B, the Hamiltonian is H is equal to minus omega Sy, where Sy is an operator. The state of the system at time t equal to 0 is the plus state, or the up state as we call it, where Sz operating on the plus state will give you an eigenvalue of plus h bar by 2, and the Sz operating on the minus state will give you minus h bar by 2. The question asks that if Sz is measured at a later time t, then what is the probability to get a value minus h bar by 2? Okay. See, for these kinds of questions, the thing that you have to know is a fundamental thing related to quantum mechanics, that a state in quantum mechanics evolves in time according to a unitary operator, which is given by e to the power minus I h t by h bar. Okay, so psi at time t will be given by e to the power minus I h t by h bar operating on psi at time t equal to 0. Okay, this is called the postulate of unitary evolution of a quantum state. Okay, now Hamiltonian is given in the question and is equal to minus omega Sy. Okay, and Sy is actually h bar by 2 into sigma y, where sigma y is the Pauli matrix. Okay, so if you put the value of the Hamiltonian and Sy is equal to h bar by 2 into sigma y, what you get is that psi at time t will be equal to e to the power I into omega into t by 2 into sigma y operator, and this whole thing will be acting on the plus state. Okay, so see, if you expand this operator e to the power I into omega t by 2 into sigma y operator as a series, you would get different powers of sigma. Okay, so sigma y, sigma square y, okay, sigma y square, sigma y cube, all will be acting on plus state. So let us see what those operations give us. So sigma y, when it operates in the plus state, you can see that it gives you I into the minus state. Similarly, when sigma square acts on the plus state, that means sigma y will actually act on this I into minus state. Okay, so that in effect gives you plus state. Then sigma cube will give you again I into minus state. Okay, and therefore if you, let's say, generalize this result um, to the case when sigma y to the power n acts in the plus state, it will give you I into minus state if n is odd, and it will give you plus state if n is even. Okay, so if you collect all these results and write e to the power, write the result of the operation of the exponential operator on the plus state, you would get something like what is written here, which is summation of n equal to 0 to infinity 1 by 2n factorial into I omega t by 2 to the power 2n. This whole thing uh, times the plus state plus again a similar uh, series multiplied with the minus state. See, all these plus states actually come from n is equal to even, as was shown earlier, and all these minus states come from the n values which are odd. Okay, the n values which are odd, and therefore we have written like this, where the 2n 2n accounts for the even nature of those n's, and 2n plus 1 accounts for the odd nature of those n's. Okay, so if you look at it carefully, the first parenthesis, the term inside the first parenthesis is nothing but actually a series representation of cosine of omega t by 2, and the second parenthesis is actually the series representation of sine omega t by 2. So okay, so if you write cosine of omega t by 2 as a series, as a Taylor series specifically, you will get a result similar to the first parentheses, and if you expand sine omega t by 2 as a Taylor series, you would get a result which will be equivalent to the second parentheses. Okay, so psi at time t actually comes out to be cos of omega t by 2 times the plus state minus sine of omega t by 2 times the minus state. Okay, so now if you operate sz on this psi at time t, okay, now why are we measuring this? Why are we operating sz on psi t? Because we want to see what is the probability of minus h bar by 2 coming out of this measurement or operation. Okay, so here you can see that when sz is acting on psi t, or in other words, you're measuring the value of sz on psi t, the probability that you will get minus h bar by 2 is actually related to the second coefficient. Okay, the coefficient which is multiplying the minus state, because minus h bar by 2 is the eigenvalue of the minus state when you measure sz on that state. Okay, therefore probability of getting minus h bar by 2 will be sine square of omega t by 2. Okay, so the third question is, a quantum particle of mass m is in a one-dimensional potential of the form Vx is equal to half m omega square times x square if x is positive, and it's infinite if x is less than equal to 0, where omega is given to be a constant. So it asks which one of the following represents the possible ground state wave function of the particle. That means there are some graphs given corresponding to the possible ground state wave function of the particle. Okay, see, again, to know what will be the ground state of the system, you need to know the potential. And what's the potential here? The potential is, it looks like a harmonic oscillator in the positive x side, but it is an infinite barrier in the negative x side. Okay, so it's kind of a half harmonic oscillator. Okay, so these are the four options that are given in the question, and you have to decide which one among these four is a possible ground state wave function of the particle. Okay, now let us plot the potential. The given potential is half m omega square x square, which is a parabola if x is positive, and its infinite wall or an infinite barrier starting from x is equal to 0 up to minus infinity. Okay, so Vx is basically a half parabola. Any wave function corresponding to this potential has to have a property that it goes to 0 at x equal to 0. Why? Because in the left side of x equal to 0, there is an infinite wall which the particle cannot cross. Since the particle cannot cross this infinite barrier, therefore, the probability to find the particle at x equal to 0 should go to 0. And so, any wave function has to start from x equal to 0 with a value of 0. Okay? Now, the second thing that you need to know is that for any one-dimensional potential, psi nx, where n is the quantum number associated with the state, okay? So the nth state has n minus 1 nodes. Here n is the quantum number associated with the given state, okay? Now, since here we are talking about the ground state, therefore, the ground state should have n minus 1 node. Now, n for the ground state is what? N for the ground state is 1. Therefore, the ground state should not have any node. Now, since it should not have any node, it means that the ground state wave function should not cross the x-axis anywhere. That means it should not intersect the x-axis, okay, at any point in the positive x-axis. Now, if you know these two properties and you look at the given options, you can easily see that by the first property, A and D are eliminated. A and D cannot be the right answers. Okay? From the first property itself, you can eliminate those options. Now, if you talk about B and C, in C, the wave function actually cuts the x-axis. So this cannot be the case because the ground state cannot have any node. So the only possible choice is option B, where it is shown that the wave function is 0 for the negative x side, which it has to be because the negative side is an infinite barrier, and therefore the probability to find the particle in the negative x side has to be 0. And in the positive x side, the wave function starts from the wave function starts with the value 0 from x equal to 0, and again goes to 0 at x is equals to infinity with a maxima in between. So it doesn't cut the x-axis, okay? And this is what we wanted. So the correct answer is B here, okay? So the question is, the wave function psi x is equal to a into e to the power minus b square into x square by 2 for real constants a and b. This psi x is a normalized eigenfunction of the Schrodinger equation for a particle of mass m and energy E in a one-dimensional potential v of x such that v of x is equal to 0 at x is equal to 0. So it is asking which of the following is correct. So you have to find v and you have to find e. Okay. So with these kind of questions, there's a simple thing that you can do is that you put back the psi given in the question in the Schrodinger equation. Okay, so if you put back the psi and then do the differentiation, okay, so after 2 differentiations, you would get a result which will be h bar square into b square by 2m into 1 minus b square into x square plus v of x times a into e to the power minus b square into x square by 2 is equal to e into a into e to the power minus b square into x square by 2. Okay. Now, since this exponential term occurs on both sides of the equation and the exponential term can never be 0, therefore, what you can write is that the term in the parentheses on the left hand side will be equal to the energy which is on the right hand side. So you will get h bar square b square by 2m minus h bar square into b to the power 4 into x square by 2m plus vx, and that will be equal to E. That's the energy. Now, if you use the condition that is given in the question that v of x is equal to 0 for x is equal to 0, that means you put x equal to 0 in this equation, you would get h bar square into b square by 2m equal to E, because the other two terms goes to 0. So the energy comes out to be h bar square into b square by 2m. And if that is so, Vx can then be written as h bar square into b to the power 4 into x square by 2m from that equation itself. Now you see which of the options give this, and you see that only V is matched. E is not matched, therefore only B is the correct answer to this question. Okay, so let us see the next question. Consider a quantum particle of mass m and charge E moving in a two-dimensional potential given as V of x comma y is equal to k by 2 into x minus y the whole square plus k into x plus y the whole square, subjected to an electric field E, which is given to be lambda times I cap minus j cap. Here lambda is a constant, and I cap and j cap corresponds to unit vectors along the x and y directions. Okay. Further, the question says that let E1 and E0 be the energies of the first excited state and the ground state respectively, and you're asked to calculate the difference between those energies. Okay, this is a very good question actually. See, now what you need to do in this question, if you look at the potential, it kind of reminds you of the harmonic oscillator potential. It is not exactly similar to the harmonic oscillator potential that you usually see, because that involves x square or y square or z square or x square plus y square plus z square. But here it is a mixture. It's a kind of mixture. Okay, but still it reminds us of a harmonic oscillator. We would like to do something which reduces it to a harmonic oscillator, because in that case we know the energy. Okay, so let us see what we can do here. Okay, let's see, the potential is actually given to be k by 2 into x minus y the whole square plus k into x plus y the whole square, but the particle is also acted upon by an external electric field, and that electric field does work on the particle. Because it does work on the particle, it also contributes to the potential energy of the system, and the potential due to the electric field acting on the particle will be given by E into E dot dl, and dl, because it's a two-dimensional case, therefore dl will be dx into I cap plus dy into j cap. If you do that, you would finally get the potential due to the electric field acting on the particle to be E into lambda times x minus y. Now if you see this carefully, you kind of have a coordinate system, the usual coordinate system x and y. Now let's say we rotate the coordinate system by 45 degrees. Let's say we rotate it. Okay, if you rotate the coordinate system x and y, it will become something like capital X and capital Y, which is shown here actually. So capital X and capital Y is actually a rotated coordinate system. Okay, if you do this, if you do a rotation of 45 degrees of the x and y coordinate system, you would get the capital X and capital Y. Now this capital X, I'm defining this capital X to be the x minus y divided by root 2, and this capital Y equal to x plus y divided by root 2. Now why we're using this root 2? See, it is because we just want to rotate the system, and in rotation you don't want to change the distance of a point from the origin. Just by rotating rotating a system, let's say a point, you're trying to rotate a point about the origin. Rotation actually means that you're not changing the distance of the point from the origin, and it means that you need to preserve the distance. How are we going to preserve that distance? It is by orthogonal transformations. And if you do orthogonal transformations, you make sure that unit vectors remain unit vectors even after rotation. Okay, so x minus y by root 2, if you write it in vector notation, you would see that it's actually a unit vector. If you rotate 1 comma 0 by 45 degrees about the origin, you would get a point 1 by root 2 comma 1 by root 2. Okay, and because of that, we are taking, or we are defining, the new capital X to be x minus y divided by root 2, and the new capital Y is equal to x plus y divided by root 2, because of the same reason. Okay, Now, if you take these two definitions, okay, and write the potential as 1 by 2 into 2k. Now we are writing 2k. Why we are writing 2k? Because we are introducing a root 2 in the denominator of x minus y. Therefore, to compensate for that 2, you are multiplying a 2 in the numerator. Similarly, for x plus y, you are introducing a root 2 in the denominator, and therefore you are writing a 2 in the numerator. And if we are also taking out half, and to compensate for that, you are again multiplying a 2, so the k actually becomes 4k in that case. Okay, and the last term again, in the last term again, you're introducing root 2, and therefore you're multiplying a root 2 in the numerator. Okay, so all these things become 1 by 2 into 2k into capital X square plus 1 by 2 into 4k into capital Y square plus root 2 into e into lambda into capital X. Now see the first and the third term. The first and the third term can be combined together to form a complete square, and that will give you x plus e lambda by root 2k, the whole square, and a constant will have to be taken out, and that will be equal to e square into lambda square by 2k. Okay, and the second term remains as it is, which is 1 by 2 into 4k into capital Y square. Okay, now if you see the system, if we define, let's say, x plus e lambda by root 2k as a new capital X dash, and the y coordinate can be redefined to be y dash. Okay, so what you're left with here is 1 by 2 into 2k into x dash the whole square plus 1 by 2 into 4k into y dash the whole square minus a constant term which is e square into lambda square by 2k. Now this looks like a harmonic oscillator. Okay, so what we have done here is that first we have rotated the coordinate system. Okay, and then along the new x-axis we have translated the system by e lambda by root 2k. Okay, so after doing these transformations, you got a new coordinate system in which the system looks like a harmonic oscillator. Okay, so for this potential you can write the energy as n1 plus half into h bar times root over 2k by m. Now, what is this root over 2k by m? It is actually the omega associated with the x direction, because we've reduced this potential to this form, that's 1 by 2 into 2k into x dash the whole square for the x direction. The associated omega in the x direction would be equal to root over 2k by m, and similarly for the y direction the omega will be root over 4k by m. Therefore, the energy will be written as n1 plus half into h bar into root over 2k by m plus n2 plus half into h bar into root over 4k by m. And the constant term will be there as it is, minus e square lambda square by 2k. Okay, so the ground state energy will correspond to n1 equal to 0 and n2 equal to 0, which will give you E naught. And the first excited state will be given by n1 equal to 1 and n2 equal to 0. Why not n1 equal to 0 and n2 equal to 1? Because the omega associated with the y direction is higher. So if you increase the second quantum number by 1 unit, it will get you to a higher energy level than if you increase the quantum number n1 by 1 unit. Okay, therefore the first excited state will be corresponding to 1 comma 0 and not 0 comma 1. I hope that part is clear. So now if you calculate E1 minus E0, you would see that the second and the third terms cancel with only h bar into root over 2k by m. Okay, so this is the answer to this question. So the answer, if you see, is A. Okay. So the next question is, consider a quantum particle in a one-dimensional box of length L. Okay. It's given that the left wall of the box is at x equal to 0 and the right wall of the box is at x is equal to L. The particle is in the ground state at t equal to 0. Okay. Now it says that if you suddenly change the length of the box to 3L by moving the right wall, what is the probability that the particle will be found in the ground state of the new system? Okay, immediately after the change. So to calculate the probability, you would need to calculate the inner product of the old ground state with the new ground state. Okay, because the square of the modulus of the inner product will give you the probability of of the particle to be found in the new state. Okay, so the old wave function, ground state wave function, is given by root over 2 by L into sine of pi x by L. Okay, this is the standard result of 1D box, and the new wave function will be root over 2 by 3L, because 3L is now the length of the box, into sine of pi x by 3L. Okay, so the probability that the system is found in the ground state of the new system would be, as I told, the inner product of psi 1 dash x with psi 1 x, and then its modulus squared. Okay, now how do we find that out? This inner product is actually equal to the integral of psi 1 dash x into psi 1 x into dx. Okay, from 0 to 3L actually, but we're writing here L. Why? Because from L to 3L, psi 1 x is actually 0. So that will not make any contribution to the integral. The only finite contribution will come from 0 to L. Therefore, we are writing here 0 to L. Okay. So if you substitute psi 1 x and psi 1 dash x, okay, in the equation, in the integral, you would get a very standard integral, which will be sine of pi x by 3L into sine of pi x by L. So you use the trigonometric identity, which says that cos a minus b minus cos a plus b is actually equal to 2 sine a sine b. Okay, using that you can find out the integral, and it would come out to be 81 by 64 pi square. Okay, so this is the probability that the particle will be found in the new ground state. Okay, so let us see the last question for today. A one-dimensional harmonic oscillator is in the state psi, which is given by summation infinity of 1 by root over n factorial times ket n. Okay, where n is the normalized energy eigenstate with eigenvalue n plus half into h bar omega. The question says, let the expectation value of the Hamiltonian in the state psi be expressed as half into alpha into h bar omega. Okay, so this alpha is unknown here. You have to find the value of alpha. So how to go about finding that? See, first of all, we write psi as given in the question. We operate Hamiltonian on that psi. Okay, now why we are operating Hamiltonian in that psi? Because we are to find the expectation value of the Hamiltonian on that psi. Okay, and to find the expectation value, you need to find out psi h psi. Okay, and therefore we are operating h on psi. So if h operates on psi, what you would get is n cap plus half h bar omega operating on summation of 1 by root over n factorial times ket n. Now this n here, n cap here, is the number operator, which when acts on ket n gives you an eigenvalue of n. Therefore, the result of this operation would be actually summation of n equal to 0 to infinity into h bar omega divided by root over n factorial into n plus half, okay, which is the eigenvalue of this operator, times ket n. If you take the inner product of this with psi to find the expectation value, what you would get is summation of n equal to 0 to infinity, summation of m equal to 0 to infinity, okay, into 1 by root over m factorial into bra m into n plus half into h bar omega ket n into 1 by root over n factorial. We're using two different indices for the ket psi and bra psi just to avoid confusion. Okay, now you see from here that there will be many inner products in this. Okay, but the inner products involving m and n, when m and n are not equal, will all be 0. Why? Because all the n in this question are given to be orthonormal states. If they are orthonormal states, the inner product between any two of them, if they are not equal, they have to be 0. So the only thing that will survive among these is those inner products which have inner products of n with n. Okay, therefore psi h psi comes out to be summation of n equal to 0 to infinity 1 by n factorial into n plus half into h bar omega. Okay, now this would have been the expectation value, but it is not. Why? So psi in the given question is not a normalized state. So if it is not a normalized state, what you would need to do is to divide this psi h psi by psi, inner product of psi with psi, which is again double summations of 1 by root of m factorial into inner product of m with n into 1 by root of n factorial. Again, since n, all the n's are orthonormal states, therefore all those inner products which involve different n's will go to 0, and the only thing that will survive is the inner products with same n's. And since there are orthonormal states, obviously n, the inner product of n with itself will give you 1. So the summation will reduce to, double summation will reduce to a single summation, which should be summation n equal to 0 to infinity of 1 by n factorial. Okay, if you divide psi h psi by this quantity, what you would get is summation of n equal to 0 to infinity 1 by n factorial into n plus half into h bar omega divided by sigma of n equal to 0 to infinity 1 by n factorial. Okay, so this can be broken into two parts. The first term is involving summations, and the other term is a constant, which is half h bar omega. Okay, now to solve for the first term, what you need to look at is uh, e to the power x can be written as a summation of x to the power n by n factorial. Okay, now if you put x equal to 1 in this relation, you will get summation of 1 by n factorial equal to e. That means the denominator is actually e. Okay, now let's say we differentiate this relation. That's e to the power x equal to summation of n equal to 0 to infinity x to the power n by n factorial. If you differentiate this equation, you would get d dx of e to the power x will be equal to summation of n equal to 0 to infinity n by n factorial into x to the power n minus 1. Now again, if you put x equal to 1 in this equation after differentiation, again you would get e, but now this time it will be equal to summation of n equal to 0 to infinity n by n factorial. That means the numerator is also equal to e. So e by e will give you 1. So 1 plus half is 3 by 2. So the expectation value of the Hamiltonian is actually equal to 3 h bar omega. Therefore, alpha is actually equal to 3. Okay. So I hope that I have made you understand how to go about solving the questions. Okay, I've tried to give a detailed solution to every question so that you get to know how to proceed for a particular question. Okay, I'll be coming up with more videos on different subjects also. So thank you.